What's up everybody, this is Wallace from A3Academy, and today we're going to be talking about standing waves. So to understand standing waves, just take a look at this video real quick. And you can see there's this guy who's moving this rope up and down in a certain motion. And this motion is at a certain frequency, but when he moves the rope back and forth, he creates these waves that propagate throughout the rope and move all the way to the end where the rope is fastened to the pole. And once it reaches the pole, the wave actually bounces back and interferes with the other waves that he's creating. So what ends up happening is that you don't really get a wave that's visible in the rope, but instead a bunch of conflicting waves that are interfering and canceling each other out. And so what you will end up with is this jumble of waves that are occurring in the rope. You see that it's not in a fixed pattern, but it's all random looking. Now, the minute he starts vibrating the rope in a specific frequency, that jumbled mess turns into something very orderly. And you can see that the rope now has these two sections that are vibrating up and down, and in the middle the rope seems to be staying in the same place. And this formation is what's known as a standing wave, because it seems as if the wave is not moving anywhere, but instead has these sections that are moving up and down. Now this rope here looks something like this. Now this rope has several sections here in the standing wave. The standing wave has what's known as a node, which is the point in the rope that stays in the same position, and these antinodes, which are points on the tip of the crests and troughs of the wave that are moving up and down. Now, in order for an object to be moving in a standing wave, it needs to be vibrating in certain frequencies, and those frequencies are known as harmonics. And the lowest harmonic, or the lowest frequency which can create a standing wave, is known as the fundamental frequency. And the fundamental frequency can be calculated pretty simply with this formula: F equals V over 2L, where F is the fundamental frequency, V is the velocity of the wave in the rope or the object, and L is the length of the rope or object. The fundamental frequency, another name for it, is known as the first harmonic. And the first harmonic is just simply represented with this F here. The second harmonic, also known as the first overtone, is 2F. The third harmonic, or second overtone, is 3F. And as you can see, there's a pattern here. The fourth harmonic is going to be 4F, and so on. Now the nth harmonic, or the n minus 1 overtone, is just going to be n times F, the fundamental frequency, where n is just an integer. So the different harmonics, or the different overtones at which a standing wave can be vibrating at, are just integer multiples of that fundamental frequency F. Now, standing waves are required in instruments such as the violin. Violins operate in such a way that standing waves are formed within the strings that are secured on both ends of the violin. And the same occurs with drums. When you strike a drum, it'll actually create a standing wave that operates at a particular frequency that will produce a particular sound. So to cap it all off, let's do an example problem. So if the third overtone of a string has a frequency of 300 Hz, what is A, its fundamental frequency, and B, its second harmonic? So the third overtone, as we discussed earlier, is the same as the fourth harmonic. And the fourth harmonic is just 4 times the fundamental frequency. If we know that the third overtone, or the fourth harmonic, has a frequency of 300 Hz, then 300 Hz is just 4 times the fundamental frequency, and F is just 75 Hz, which is the answer to part A. The second harmonic, as we had discussed earlier, is just 2 times the fundamental frequency, and therefore it's just going to be 2 times 75 Hz, or 150 Hz. So that's all you really need to know about standing waves and the different harmonics and overtones. If you like what you were watching, then definitely come and subscribe to us on YouTube if you haven't already. Like us on Facebook, follow us on Twitter, and as always, the more you know, the better you are.
Found a way to be happy.